Hello everyone, welcome back to Peter's Mythical Math. Today we're going to be talking about a core concept of calculus called the integral. So what is an integral? An integral is a lot of things, but the easiest way I would describe an integral is it's the reverse of a derivative. So what does that mean? Let me show you what that means. So when you have the function x cubed and you take the derivative, you get 3x squared. However, if you were to do the opposite of that, and you were to have the 3x squared already taking the derivative and take the integral of that, it goes back to the original function before you took the derivative. So it's kind of undoing what the derivative has done. So in this case, x cubed is the answer to the integral of 3x squared. And they are related. That's a very key concept of integrals, is they're related to the derivative of that same function. So the plus c right there, you have to put because it's a constant. And whenever you take the derivative of a constant, it goes to 0, right? But when you take the integral, you don't know what the constant is or if a constant's there. So you have to put the plus c in order for it to make sense. Okay, you may be thinking, cool, that's what an integral is, but how do you find the integral? Well, the answer to that is there's a whole bunch of different ways, actually. You got the power rule, integration of logarithmic functions, integration of trig functions, integration by parts, integration of inverse trig functions, integration by substitution, and more. And some of these even take some of these methods and combine them into one, which is just crazy that people have come up with this. Okay, so let's move on. The definite integral. What is a definite integral versus indefinite integral? So definite integral is an integral taken over a period on the function. So you go from a to b on x, and then whenever you take the f of x, you get the antiderivative of that, which is, like I was saying, like the opposite of what you had earlier. So you're taking basically reversing it to get back the function before you took the derivative. So once you do that, you take the original function and then you evaluate it at b, and then you minus evaluation at a. So f of x is what we could call the antiderivative of f of x, meaning that whenever you take the derivative of f of x, you'll get back f of x. So it's kind of like the big f of x is kind of like the version before this, because this is after you take the derivative and this is before you take the derivative. So what would be an example of this? Let's say on the interval 0 to 2 of 3x squared dx. So when you do that, you get x cubed plus c, and then you evaluate it at 2 and 0. And so how exactly does that work? You take 2, plug in an x. So you get 8 plus c minus 0 plus c. You plug in x equals 2 for the x. And that gives you an answer of 8. So the next thing we're going to be talking about is the characteristics of integrals. Integrals have very unique characteristics for each other that are very super helpful to have and to help you solve problems. So the first thing we're going to talk about is that when you have an integral of f of x plus g of x, you could split it up. So you could just take the integral of f of x, and then on a separate one, you could add over the integral of a to b of g of x. So you could split up with the addition and subtractions, which is super helpful to know. Another thing you could also do is whenever you have a constant times a function in the integral, you can just simply pull out the constant. So yeah, you pull it out, and so you don't have to make the numbers inside the integral much more messy. So you make it simpler by pulling out the c. And then the last thing is that whenever you have an interval from a to b of f of x of d of x, and you swip the a and the b, then you just take the negative of the other one. So yeah. Okay. And the next thing you may be wondering is, okay, cool, I know what an integral is and I see how it does, but how do you solve the integral? I got you, bro, don't worry. We're going to talk about quite a few common ways to solve integrals that you will see probably pretty often on the test. So the first thing in integrals is the power rule. Power rule is pretty similar to the power rule you learned in derivatives, but it's a little bit different. So in this case, whenever you have a function x to the n power, what you want to do is you want to add plus 1 to the n, and then you want to divide by that n. And that gives you plus c. And you want to do this for all n's not equal to -1. So what does that look like here? Let me show you. So when you have the same problem, you have the integral of x cubed plus dx, you're going to add plus 1 to the power, and then you're going to divide by that power plus 1. So you're going to have x cubed plus 1, so x to the 4th, and then you divide that by 4. And it gives you x to the 4th over 4 plus c. Remember to always have the plus c because we don't know if there's a constant there. And the one really cool thing about integrals is you can check to see if they're right. You just simply take the derivative of it, and that should give you the original function. So if you take the derivative of x 4th to the 4th, it gives you 4 over 4, and then it gives you the power of 4 minus 1, which is just x cubed. So 1 times x cubed is x cubed. So it works out. It's pretty cool to see that, like, you know, integrals and derivatives are like very related to one another. And so that's like a perfect example of just showing that. So what we just found was the definite integral. So the indefinite integral is basically finding the generic form of the definite integral. So what does that mean? That means it's just like you don't solve for anything. You just write it out. So you may be wondering, okay, so why not -1? Why can't I do that when the power is -1? So the answer to that is it's different, it turns out. When you're solving for the inverse of x, it actually ends up being the natural log of the absolute value of x. It is not 0 over 0, and they are not the same. So I'm sure you learned in the derivative section that the derivative of ln of x is just equal to 1 over x. And so, yeah, they're the same. Okay, so moving on, we're going to go to another big topic in integrals is the trig functions. So the integral of cosine of x, kx dx is equal to 1 over k times the sine of kx plus c. And then sine of kx is equal to, the integral of sine of kx dx is equal to -1 over k cosine of kx plus c. And then e is just one of really simple one. It's just equal to itself plus c. And then if it's multiplied by something, it's just equal to 1 over k e to the kx plus c. So you basically pull out the inverse of the constant that you're multiplying by x. So an example of this would be integral of sine of 8t plus 20 cosine 9t. And then the integral of sine 8t, you split it up from that rules we were talking about earlier, plus integral of 20 cosine 9t. And then you have to pull out the 8, so it's -1/8 cosine of 8t plus 20 over 9 sine of 9t. And the reason you flip the sign here, why you get a -1/8 instead of 1/8, is because when you take the derivative of cosine, you're going to get negative sign. But it's positive here. So a negative times a negative will give you a positive. And then for here, whenever you take the derivative of sine, that means you're just going to get cosine. So this one, you don't need to flip the negative sign, so you keep it the same. Okay. Moving on, we're going to talk about different examples that you would probably see similar to the ones you would probably see on a test. So integral of e to the x minus 4 sine x dx. So again, you want to split it up again. So you get integral of ex dx minus the integral of 4 sine of x dx, which gives you e to the x is just e to the x, and then the integral of 4 sine of x is equal to -4 cosine of x plus c. The reason it is that way, again, because remember, whenever you take the derivative of a cosine, you get a negative. But this case, it's positive. So you want to, just do that. And then once you do that, you get e to the x plus 4 cosine of x plus c, and that should be your answer. And then you could always check. So if you take the derivative, right, you'll get e to the x. And if you take the derivative of 4 cosine of x, you should get -4 sine of x. And then the derivative of a constant is 0. So let's see, is that right? Yep, it is right. So you get -4 sine of x, and then you also get e to the x. And yep, that's right. Okay. Next, we're going to take the integral of 8x minus 4e to the power of 5 minus 2x dx. So again, you want to split it up like you always do. 8 of x dx minus the integral of 4e to the 5 minus 2x. This is simple because the power rule, you just add 1 and then you divide by that power. So you get 8 over 2 times x squared. And then over here, you get a negative 4 divided by negative 2, or yeah, e times e to the 5 minus 2x. And so the reason you multiply by negative 2 over here is because the only thing you care about is the constant here. So, and the constant for the x is negative 2, because when you take the derivative of this, right, this is going to be 0, and that's just going to be negative 2. So 4 over negative 2, and minus, and then you add that all up, you'll get 4x squared plus 2e to the 5 minus 2x, and then don't forget the plus c, because remember, we don't know if there's a constant there or not, so we have to add 1. And then for the very last problem, we have integral of theta plus secant squared of theta d theta. So again, split it up. And this one's a little bit more tricky because we didn't quite talk about it, but if you were to think about the derivative of what will give you secant squared, that's got to be the tangent, right? Because the derivative of a tangent is secant squared. So this one we just simply just do the power rule. So you add the power plus 1, so 2, and you divide by that power, so 1/2 times theta squared. And then you're going to add the tangent of theta, because the derivative of tangent of theta will give you secant squared of theta. And then you're going to add the plus c, because we don't know about the constant at the end. Alrighty. That's it for today. Thank you for tuning in, and I hope I'll see you again in the future.